Greetings, everyone. Compliments to 2022. It's the greatest opportunity that we meet again for 2022. Today, we'll be doing number patterns, sequences, as well as the series grade 12 work. Without wasting much time, please, if it's your first time to tune in, don't forget to subscribe on our Yebo Tutor, and also don't forget to comment and like, and also you're free to ask questions through the comment section, or you can call us via Zoom. Thank you so much. Let's start. So I'm gonna start with an overview of our grade 12 work, and I'm gonna give you just a short summary of the important concepts in the on the topic of sequences of and number patterns as well. Okay, so the first thing which I want to highlight is just to revisit grade 11 number patterns, because they are so important that you take care of. So the first thing which I want to highlight is that in grade a sequence basically is just a pattern of numbers on the way the numbers are set, that they can have a constant difference, or a first constant difference, or a second constant difference, or a constant ratio. So firstly, I want to go and check, and we want to do an overview on quadratic sequences. So as we were taught about the quadratic equations in grade 11, which means now we are now wanting to look at quadratic sequence. So first point about quadratic sequence is that they have a general term Tn, which is equivalent to an squared plus bn plus c. So this is our general form. So when they say calculate the Tnth formula, or the nth formula, or the general formula, you must always know that we use Tn is equal to an squared plus bn plus c. Now, whilst we are still here, we want to say, how do we calculate our value of a? So bear in mind that on a quadratic sequence, we have the second constant difference. So in other words, the second difference is the one which is constant and is represented by the letters, a small letter d. So how do we calculate the value of a? So it's also important that you know that a is calculated by saying 2a is equal to d, where d is the constant, second difference. Okay, gonna do an example on that. Now, after you find our a, we know that then our a will be equal to the constant difference divided by 2. So after we find our a, now we want to determine the value of b. So how do we do that? Our b is always equal to 3a plus b is always equal to term 2 minus term number 1. Then now, since you have already calculated the value of a, now it's now easy. You substitute your value of a on this point so that we can make b the subject of the formula. Then this is also an important equation which you must always bear in mind, that you start by calculating a by a is equal to the constant difference over 2. Then the value of a which you got initially, you will substitute it so that you can be able to make b the subject of the formula and get the value of b. And in order for you now to get c, now I hope you are seeing that we are trying to go from a, b, and c, so that how you'll be able to calculate them. So now, in order for us to calculate the value of c, now we know the value of a, now we know the value of b. Now we must calculate the value of c, and we equate it to term number 1. So now we make the value of c the subject of the formula, then we calculate the value of c. So basically, on quadratic sequence, just to give you an overview, is that it has a second constant difference. Then after that, we also have to know that the first difference of a quadratic sequence forms an arithmetic sequence. But now, on this quadratic sequence, what is important is to be able to know how to determine the general formula, the nth form, which is Tn is equal to an squared plus bn plus c. Then you'll be able to determine your Tn formula. Then you find your value of a by saying 2a is equal to d. Then you make a the subject of the formula by dividing both sides by 2, ending up having your a be equivalent to the second constant difference divided by 2. Then in order for you to calculate the value of b, it's 3a plus b is equal to t2 minus t1. Then now, since initially you calculated the value of a, now you use that value of a and substitute it on this equation, which is 3a plus b, so that you can be able to find the value of b and make b the subject of the formula. Then now we know the value of a, we also know the value of b. Now we want to calculate the value of c. So in order for you to calculate the value of c, we say a plus b plus c is equal to t1. Then now we make this our c the subject of the formula so that we can get its value. That's an overview on arithmetic, on the quadratic sequence. Now in grade 11 as well, we were taught about the arithmetic sequences. We were taught about the arithmetic sequences. So the arithmetic sequence now, they are known that they have the first constant difference. They have the first constant difference. So now, since they have the first constant difference, how do we calculate the general form, or the general term, or the nth term? We calculate it by saying Tn is equal to a plus n minus 1 multiplied by d. So now someone will ask me, what is a? A is equivalent to your term number 1, which is your first term on that sequence which you are given. And what is your d? What is your d? Your d is now the first constant difference, okay, which is illustrated by a small letter d. Then you'll be able to calculate your Tn formula. But now on the arithmetic sequence now, we have, let me just go to this as well. We are also taught now about the arithmetic let me just do this. So bear in mind, let me just illustrate something here which is important. So we say that Tn is equal to a plus n minus 1 times d. So for now, for instance, we want the first term of the arithmetic sequence. We want to illustrate it in the algebraic letter. So now we want T1, where there's n, you substitute by 1, it's going to be a plus 1 minus 1 times d, and you end up having your first term as a. Now we want term 2, your term 2 will be a plus 2 minus 1 times d. Then you end up having a plus d. T number 3 will be equal to a plus 3 minus 1 times d. Then now we will end up having a plus 2d, and so forth and so forth. So basically now the sequence of the arithmetic the arithmetic sequence now can be written like a, then we also have a plus d, we also have a plus 2d. As you can see, and as I've illustrated for you, that's the term 1, term 2, term 3. We just substitute to our general nth formula so that you can find this the terms of the sequence. So now we have what we call the arithmetic series. I know many people watch series, like you maybe watch soapies. You see, when you're looking at soapies, we are having, for instance, maybe Uzalo, maybe Skim Sam. Bear in mind, in those shows, they are series, they are soaps. In other words, where they left today, it's what's gonna proceed from tomorrow. It's not like they will show you today something, then tomorrow there's something new, different from today's episode, which in other words, they are corresponding. So in arithmetic series, since we have said that this is our sequence of an arithmetic sequence, so now an arithmetic series is the summation or the sum of the arithmetic sequence. So basically now we are saying a plus, since our first term T1 it's a, instead of putting a semicolon, since we said no man, this series is, so we must put a summation because we are adding them where we left, we are adding so that they can correspond. So we are having a plus, then we have plus a plus d. This is our T2, we know that. And we also have a plus 2d, and just like that. So these are our series. So we have a formula to calculate the sum of the terms of a series or of a sequence. So we calculate them by using the formula Sn is equal to n divided by 2a plus n minus 1 times the constant difference, which is dE. Then you'll be able to calculate the sum of terms of your series. Now, that is our arithmetic series. To sum up again on the arithmetic sequences, we say that it has the first constant difference, and in order for you to calculate or determine the general term, we use the formula Tn is equal to a plus n minus 1 multiplied by d, where your a is your first term of the sequence and your d is the first constant difference. And now I say that we have arithmetic series, and we said series is something which is the sum of the arithmetic sequence. What was happening in the sequence, now we are summing it up. It's now corresponding. What's happening today on a series show, it's what's gonna continue. It's a continuation of the process of the sequences. Then we end up having that we have this, when they always tell you, no, calculate the sum of terms, maybe up to 20 terms, you use this formula. Please, if you have any question, please don't hesitate to ask on the comment section. We are here to assist you. You ask, we will be able to assist you. Thank you. Now, moving forward to the geometric now. This is grade 12 stuff. Geometric sequence. So a geometric sequence, it has a constant ratio. It has a constant ratio. So in other words, it has a constant ratio which is denoted by a small letter r. So how do we find r? R is always equal to your term 2 divided by term 1, always the same as term 3 divided by term 2, always equal to term 4 divided by term 3, and so forth. So that's how you can calculate your constant r. So what is our Tnth formula? Our Tnth formula of a geometric sequence, it's Tn is equal to a Rn minus 1. This is our Tn formula. So just like what we did in a sequence of arithmetic, we can also do it here so that we can determine the terms which we have. So T1 is equal to a R1 minus 1, and we know that 1 minus 1 is equal to 0, and anything to the power of 0 is equal to 1. So a times 1 is just a. Now we want to determine our T2. Our T2 now, which other words, where we see n, we substitute by 2. So it's going to be a R2 minus 1. Then we end up having a R. T3, where we see n on our nth formula, we substitute by 3. Then we end up having a r, and then 3 minus 1, which is the same as a r squared. Then you can also determine T4 until we reach to Tn. Okay, so now basically the sequence of a geometric series sequence, it's a is the first term, AR is the second term, AR squared is the third term, then so forth until we reach to AN, ARN. Okay, so this is our sequence which we have here. So now, as the arithmetic again, in this one also we have a geometric series. So we say that a series is whereby we are summing up the terms which we have on our sequence. So again, in this one, we are just trying to say our term 1 plus term 2 plus term 3 plus term 4 plus term 5 until Tn. So it's just like we said this is our sequence, so it's the same as a plus ar plus ar squared plus until we reach to ar to the power of n. Until we reach to a to the power of n. And also the last thing which I want to highlight on the geometric series. So on the geometric series, we have what we call the convergence of the sequence. So when we are talking about the convergence of the sequence, now we are talking about let me just write just do this, convergent geometric sequence series, sorry. So a convergent geometric series, it is when a geometric series only converge when r is less than -1 or r is greater than -1 or r is less than 1. So we are saying that a geometric series, GS representing geometric series, will converge when -1 is less than r is less than 1. So this is the only case where a geometric series can converge. If your r is greater than 1, it will not converge, it will diverge. If your r is less than 1 or greater than -1, that's when it will be able to converge. So in other words, now this is where now we are introducing ourselves to what we call sum to infinity. So sum to infinity is the equation which is written sum to infinity. So in order for you to calculate the sum to infinity, you must be able to determine whether your geometric series converges or not. So in order for you to use this formula of sum to infinity, you must make it a point that your geometric series converge. And in other words, you're trying to say our value of the constant ratio or our value of r is between -1 and +1. That's always the case. Please always make sure that you don't do any mistake on that. So sum to infinity is equal to a over 1 minus r. What is our a? Our a, as usual, is the first term of your series. Then our r is the constant ratio. Our r is the constant ratio. Now let me just also highlight the last aspect which is important on number patterns, which is called sigma notation. It's so important that we know the sigma notation, which is illustrated by this thingy, by this sum. Sigma notation is very useful notation for the sum of a given number of terms of a sequence. So in other words, we are trying to say that the sigma, this sign, is called sigma, and it's just illustrating, which means we are summing up the number of terms. So in other words, we are trying to sum of, we are trying, since we have a long, for instance, maybe we have 3, 5, 7, 9, 11. We are having a long number of we are having a long pattern, a long sequence. So we are trying to shorten it by using our sigma notation. So let me just make a small example. Let me just say e.g. so that you can see what I'm talking about. E.g. we are having a summation of 3k. 3k is the tn. So in other words, this portion, okay, let me just write this first. This example, we're having 3k. I'm having my k is equal to 3, and maybe I'm having 5 here. I'm just making an example. So what this means is that if we read this, which means that this read as the sum of all the terms from this term which is here, from the nth term, which is here, to the last term, which is here. So in other words, in order for you to be able to determine or understand sigma notation, you have to understand that k is equal to 3. This is an example, as I said, e.g. So in order for you to understand that, we are saying that this position, let me just use something different. So this position is illustrating the general form of your sequence, Tn. Then this is illustrating where your where is your first term of your sequence or your series. So this is where you see your first term. Okay, this is your last term. Your last term. So for instance, in this case, if they say write down the first 3 terms of the sequence, how are I gonna write that? We know that our Tn is equal to 3k, and our first letter k is equal to 3. So we must determine Tn, we must determine the first term by just substituting the value of k. So we have 3 times 3, that will be equal to 9. So in other words, that is our first term. Then another term, because bear in mind that we have 3 terms here, from 3 to 5. So we have 9 as our first term. Then now we say, when we're counting our numbers, we say 3, 4, 5. Okay, so the next term will be the fourth one, which is 3 times 4, and we have our 12. Then again we have 3 times 5, which is the same as 3 times 5, which is 15. So when we are summing up now, we are trying to say that, therefore, when we are summing up using the sigma notation, we are just trying to illustrate that we have the series, which is 9 plus 12 plus 15. So when you add these numbers, 12 plus 9, it's 21. Then 21 plus 15, that's 30, that's 36. So I was just making an example that this is what's really happening on a sigma notation. We are summing up all the terms which we have in our sequence, trying to shorten everything. Okay, for instance, this one, let's just say we are having this here. How are we gonna solve this? We're gonna solve this by just saying, let me put this plus and maybe yes. So now write this in a sigma notation form. What is our Tn in this one? Our Tn in this one, we know that our constant difference is, let me just use a good space. We are having 3 plus 5 plus 7. Let me just end there. So now what is our Tn? So our Tn is what you determine as. You just determine your Tn first, so that you can be able to use your sigma, where k is equal to where your number starts, and your n is where is the last number. Then we have your general term. I'm done showing you an overview of the 3 or 4 aspects of number patterns. If you have any question, please don't hesitate to ask your questions. Please don't hesitate to ask your questions. Okay. Now to summarize again, we started by talking about the quadratic sequences, and we say that the quadratic sequence, it's a sequence which has the second constant difference. Then we spoke about the arithmetic sequence, and we say that the arithmetic sequence, it's a sequence which is known by having the first constant difference. And we also say that on the first constant difference of the arithmetic sequence, that's where we'll be able to determine our general term. Because on our general term of an arithmetic sequence, we know that Tn is equal to a plus n minus 1 multiplied by d. Then now we also have arithmetic series. So on the arithmetic series, it is when now we are summing up the terms of the sequence of an arithmetic sequence. So we are summing up them using the formula Sn is equal to n over 2, open bracket, 2a plus n minus 1 times d. Then we went to geometric sequences, and geometric sequences, we said they are known that they have the constant ratio, which is illustrated by the letter r. And how do you calculate your r? Your r is always equal to t2 divided by t1 equal to t3 divided by t2 equal to t4 divided by t3 equal to t5 divided by t4. So it's something which is always like that, that your the term which is in front divided by the term which is behind, so that you can be able to determine. And also the same note, we have the geometric series. Now, is there anyone with any question? Please don't hesitate to ask question. We are here to assist you. All right. Let me just do maybe 3 examples, 4 examples on this before we do many questions on this section. Okay, so let's just do our question which we have here. So on this question which I have, it reads as follows. Question 2. Okay, so question 2, that given the following quadratic number pattern. So the moment I'm gonna also try to assist you to analyze your question before you answer anything. So what they are saying is that given the following quadratic number pattern, they are already telling you what is this pattern looking like. So this pattern is a quadratic number pattern. So what has to come to your mind when you are reading this? Oh, it's a quadratic number pattern. So since it's a quadratic number pattern, you must be able to know that, oh, it has the second constant different, and after that you use the formula Tn is equal to an squared plus bn plus c, and I can be able to manipulate what I know and find what they need from me. So what now can we do now? Okay, let's check 2.1. So we are given the sequence 5 is to -4 is to -19 and -40. Now 2.1.1. Now 2.1.1. So the question on 2.1.1 is saying, determine the constant second difference of the sequence. So in other words, we want the value of d. So how are we going to determine that? So we know that t2 minus t1, this is our t1, t2. Let's use something different so that you can be able to see and notice. Just use this. This is our t1, this is our t2, t3, t4. Okay. So what we do here is that we say t2 minus t1. Even if you are given 100 here and you are given 5 here, even if it's a big number minus it's the protocol. You must say t2 minus t1. Even if you are given t2 smaller than t1, you have to do the same thing always. So in this case now, let's solve and determine our constant difference. So our constant difference, we will say -4 minus, so t2 minus t1. So t2 minus t1, so we're gonna say -4 minus 5. Sorry, -4 minus 5. Then we know according to our maths it's gonna give us -9. Then now here t3 minus t2, -19 minus 4. Don't forget this negative, it's important. -19 minus 4. -19 minus 4. Okay, so when we say -19 minus 4, we get -15. Then we come here again, -40 minus 19. Then when you use your calculator, don't worry about many things. Use your calculator, it's always there to assist you. It's -21. Yes, -21. So this is our first difference. So this is our first difference. But we were not asked about the first difference. We want the second constant difference. So again, we do the same thing again. So this is our first difference. Now we want our second constant difference. So in other words, our second difference must be constant, must be the same. So again, t2 minus t1. So -15 minus 9, which is 15, which will give us -6. Then -21 minus 15, we got also -6. So therefore, we can conclude that our constant difference, illustrated by small letter d, is equal to -6. It is equal to -6. Now 2.1.2. Determine the nth term, Tn, of the pattern. So since it's a quadratic number pattern, as we all know, it's easy because we know how to determine our our Tn. We say that Tn of a quadratic pattern is equal to an squared plus bn plus c. So now this is our a. Now we say that we must start by calculating the value of a, and we said our a is the same as 2a is equal to the constant difference. What is our constant difference? Our constant difference, which we have calculated here, it's negative 6. So now then our a will be equal to negative 6 divided by 2, which is equal to negative 3. So basically we are having our a to be negative 3. Our a it's negative 3. Our a it's negative 3. Our a is negative 3. All right. Now we want our b now. We say that in order for us to calculate b, we say 3a plus b is equal to t2 minus t1. What is our a? We are now substituting what we have already calculated. And what is our t2 minus t1? T2 minus t1, we got negative 9. So now we have negative 6 plus b is equal to negative 9, and b will be equal to negative 9. We transpose negative 6, so when it crosses to that side, it will be positive 6. Then our b will be 3 times 3 is 9. Sorry for that mistake. Plus 9, sorry. Negative 3 times 3 is negative 9. Then we transpose it to be positive 9. So negative 9 plus 9 is going to give us a value of b, which is equal to 0. Then now we want to determine the value of c. So a plus b plus c will be equal to t1. What is our a? Our a is negative 3. What is our b? Our b is 0. What is our c? It's what we are calculating. And what is our term number 1? Our term number 1 is 5. So now we come here again, we substitute with our term number 1, which is 5. Then make c the subject of the formula and transpose every other thing. So now we have 5 plus 3. Then we end up having c is equal to positive 8. So now we are not yet done. We must say therefore Tn is equal to, what is our a? Negative 3n squared. What is our b? Our b is 0. So it's the same as 0n plus our c, which is 8. So 0 times anything is the same as 0. So it's the same as negative 3n squared plus 8. So this is our Tn. I illustrated that 0n so that you don't get confused that where is the value of b. We calculated the value of b here and it was 0. So we substitute it on our Tn equation, which is this one. So this is our a, negative 3. Our b is 0. Our c is 8. Then we'll be able to get our general term, which is negative 3n squared plus 8. Plus 8. Okay. We can proceed now. Now the question is now saying which term of the pattern will be equal to negative 2539. So when you are given that question, don't worry yourself. They're already telling you that Tn is equal to negative 25,939. Negative 25,939. So what do you do when you're given this kind of instant? It's easy. They've already given you Tn and you've already calculated your Tn, and your Tn is negative 3n squared plus 8, and now it's equivalent to negative 25,939. So now what do we do in this instant now? So in this instant, let's transpose like terms to the right hand side. So we are having negative 3n squared is equal to negative 25,939. Since it was positive 8, when it goes to that side, it will be, when we transpose that, it will be negative 8. Using your calculator again, negative 25,939 minus 8 is equal to negative 25,947. Yes, 947. 39 plus 8, it's 47. So it's negative 25,947. Now let's divide both sides by negative 3. Now we are just using your algebra skills. Then you're left with n squared. Now you'll be got this and this will cancel each other. It's gonna be 824. It's 8. Menda 119. So we have 8,649. We use our calculator, guys. Always use your calculator. Then after that, we know that we can square both sides. And when we are square, we're going to have two answers, positive and negative. These ones will cancel each other. Then n will be equal to plus or minus. Okay, don't ever forget that plus or minus 93. So in other words, this, when you use your calculator, you're going to get plus or minus 93. So if this is the same as n is equal to positive 93 or n is equal to negative 93. But when we are counting things, you will never say that negative 1, you are negative 1. You are counting maybe humans. You say, no, you are negative 1, you are negative 2. It doesn't make sense. We count whole numbers, positive whole numbers. So therefore, our n will be the positive 1. N is equal to 93 or n is not equivalent to negative 93. Don't forget to conclude because we are having two solutions. So that's how, even if it was an arithmetic term, the moment they tell you that determine which term of the pattern will be equal to something, always know that you are calculating the value of n. It's always the case that you are calculating the value of n. Okay, let me just create another question. Let me just say 2.1.4. So my question now is saying determine the 20th term. So in other words, we just need T20, or let me just say T10. Determine T10. So how do we do that? Or when they say 10th term, because that's the question which I'm not seeing here, because they usually ask it. So now we know that Tn is equal to negative 3n squared plus 8. So now they want the 10th term. So we now substitute T. Let me just remove this. They want the 10th term. So we now substitute n with 10 so that we can find the actual value on 10, term number 10. So that will be negative 3 times 10 squared. Where there is n, we replace with 10. So also in the equation where is n, we will replace with 10. Then we have plus 8. We know 10 squared is 100. 100 times negative 3. It's negative 300. Negative 300 plus 8. That will be negative 292. Please correct me. Please correct me if maybe my maths is not summing up. But yes, 10 squared 100 times negative 3. It's negative 300 plus 8. It's negative 292. I just formulated that question because I see that there is a need, because they usually ask you that kind of question, that calculate or determine the 10th term of the sequence. So I've already given you the cream. These are the 4 questions they usually ask. They will ask you the constant difference or the constant difference. Yes, they'll ask you the general form. They'll also ask that which term of the pattern will be equal to something, and they'll also ask you which term or they'll say determine the 10th or the 50th term of that sequence. Then you just have to say T10. Then also sometimes they'll ask you determine the next 3 terms of the sequence. You just have to do the same thing and determine the next 3 terms of the sequence. Since we are here, where is our sequence again? We are here. So in other words, we need the next 3 terms. So we just do the same thing. You do the same thing and you do the same thing. Those are the 5 questions which they ask on the quadratic sequence or any sequence prof. They'll always ask that kind of question. All right, thank you. Now let's move to 2.2. 2.2. Now they are saying the first 3 terms of an arithmetic sequence is 2k minus 7, k plus 8, and 2k minus 1. So we are given that the first 3 terms of our sequence is 2k minus 7, then k plus 8, and we are also having 2k minus 1. So now they are saying calculate the 15th term of the sequence. So what we have to do first is to be able to determine the tnth formula so that we can calculate the 15th term of the sequence. So what we do first, we know that according to they have already told us it's an arithmetic sequence, which means it has the first constant difference. And we know that t is always equal to t2 minus t1, also the same as t3 minus t2. So in this case, we are given t1, we are given t2, we are also given t3. So let's do the same thing. Our t2 in this case is k plus 8 minus 2k minus 7. Take mind and take into control that I putted my term 1 in brackets because there are 2 digits, because the moment you don't put them in brackets, you'll be confused. Because maybe, for instance, we will remove our brackets like here. When you remove our brackets now, you are gonna have the wrong answer, because now it's gonna just be negative 2k minus 7, of which now this negative sign is multiplying everything on term 1. Then also now this must be equivalent to our t3. What is our t3? Our t3 is 2k minus 1, and the same thing, also put them in brackets so that you don't get confused. So k plus 8 minus 2k plus 7, because negative times 2k is negative 2k, negative times negative 7 is positive 7. Then we have our 2k minus 1 minus k. Negative times k is negative k, negative times positive 8 it's negative 8. Then now let's combine the like terms. K minus 2k is negative k. 8 plus 7, that's 15. Yes, that's 15. Then 2k minus k is k. Negative 1 minus 8, it's negative 9. Now when we transpose our k to go to the left hand side, it will be negative k minus k, and we transpose our 15, it will be negative 9 minus 15. Negative k times k is negative 2k, and negative 9 minus 15, that will be negative, use your calculator, here's your calculator, negative 24. Then we want the value of k, so we divide both sides by negative 2, then our k will be equal to 12. That's the first step. Now let's determine our sequence now. So now we are just substituting here. We are now substituting here with k is equal to 12. So we're gonna first have for our sequence, we're gonna have 2 times 12 2 times 12 minus 7. Is it minus 7? Oh, yes, 2k minus 7. We also have k, which is 12 plus 8. We also have 2 times 12 minus 1. So our sequence will be 2 times 12 is 24. 24 minus 7, it's 17. Yes, it's 17. Then 12 plus 8, it's 20. Then 2 times 12 is 24 minus 1, it's 23. So now this is our sequence. Okay, we have now determined our sequence. That's why it's 5 marks. So now, since we have determined our sequence, now we must calculate the 15th term. So in order for us to calculate the 15th term, we must know our general term. So bear in mind that our general term, we must know the first constant difference. So the first constant difference, we'll be saying 20 minus 17 is positive 3. Then 23 minus 20 is positive 3 as well. Okay, so after that, we know that this is our difference, and we know that Tn is equal to a plus n minus 1 times d. What is our a? Our a is the first term, and our first term is 17. Plus, what is our n? It's n minus 1, and our d is 3. Then we solve it. 17 plus 3 times n is 3n. 3 times negative 1 is negative 3. Then we end up having our Tn, which is equal to 3n. Then 17 minus 3, it's positive 14. That's our general term of this sequence. But we are not yet done. We are told to calculate T15, the 15th term. So now we are substituting where there is n, we are putting 15. So also on our general term, where there is n, we put 15. So it's going to be 3 times 15 plus 14. 3 times 15, 45. 45 plus 14, that's 45 plus 10. 55 plus 4, 59. So our T15 must be equivalent to positive 59. So let me recap again this question. It was quite long. So on this question, we are given an arithmetic sequence which is having T1, T2, and T3. So what's important here is to understand that we must know that an arithmetic sequence, it has a first constant difference. So since it has the first constant difference, what does that mean? It only means that the T2 minus T1 is the same as T3 minus T2. It is also the same as T4 minus T3. So that's what I did here. I start by saying T2, this is my T2, minus T1, this is my T3, minus T2. And bear in mind, don't lose those brackets. They are so essential so that you don't forget that everything on term 1 is being subtracted from term 2. Okay. Then I was able to find the value of k. Then after I found the value of k, I substituted my value of k in the original sequence which we were given so that I can only have numbers and remove the algebraic letter k. So 2 times 12 minus 7, I got 17. Then 12 plus 8, it's 20. Then 2 times 12, it's 24 minus 1 is 23. So those are my terms now of the sequence. Now, that's not over. I must be able to determine my general term or my general formula so that I can be able to calculate the 15th term of the sequence. So I started by determining my general term. And how did I determine my general term? You determine your general term by using the formula of an arithmetic sequence that Tn is equal to a plus n minus 1 multiplied by d. What is our d? We calculated our d, which is the second constant difference, which is equivalent to 3. Then we substitute there, and our a is 17. Then we manipulate our digits. Then we end up having Tn is equal to 3n plus 14. That is our general formula. Now, finally, what we were asked. So sometimes use things which you're not asked to get what you are asked. Use the unknowns and manipulate the unknowns so that you can get what you were asked. So our T15 now, we are now substituting only on our general term here. So wherever there is n, we replace with 15. So also on our general term where there is n, we replace with 15. Then we'll say 3 times 15 plus 14 is equal to 59. We are done with that part. Now let me do 2.2. 2.2. We are almost there. We are almost done for our session. 2.2.2. Okay. It says that calculate the sum of the first 30 even. Underline that. Sum of first 30 even terms of the sequence. Let's look at our sequence. We're having 17 is to 20 is to 23. Then we say the constant difference is 3. Let's determine another 3 terms. So 23 plus 3 is 26. Plus 3 is 29. Plus 3 it's 32. Yes. So now, what are the even terms? Let's determine the first 3 even terms which we have on our sequence. So the first even term we have T1 is 20 plus our T2 of even number. We know that even number is any number which is divisible by 2. 23 is not divisible by 2. So we have 26 plus 32 because we want to determine the sum of the terms. So up to 30 terms. Okay, we want the first 30 even numbers. So up to 30 terms. So what do we do here? We use our formula for calculating Sn. So Sn will be equal to n over 2 2a plus n minus 1 multiplied by d. What is our a? Our a is the first term. What is our d in this situation? We know that 20. We know that d is T2 minus T1, which means it's going to be 26 minus 20, and we have our d to be equivalent to 6. So in that case, what is our value of n? We want the sum of the first 30 even terms. So now we are calculating S30, which is now equal to 30 divided by 2. Then we have 2 our a, we said it's 20 plus our n 30 minus 1 times our d6. Then now we use our calculator. So when you use your calculator, you must get, I think it's 3210. So this is the sum of the first 30 even terms. Is there anyone with any question? Please, if you have any question, please don't forget to ask. If you have any question, please don't forget to ask on the comment section. Okay, let me just do the last question, which is these two questions only, then we're done. Question 3. These are the last 2 questions which we have for the day. Okay, so on question 3, a convergent geometric series consisting of only positive terms has the first term a, which is a constant ratio r, and the nth term tn, such that the sum to infinity, don't forget that this is the summation, the sigma notation. So they're saying the sum to infinity, it's tn equal to 1 over 4. So in other words, it's starting from 3 to infinity. Okay, now they are saying that if t1 plus t2 is equal to 2, write down an expression for a in terms of r. So we are already told that, where's our 3.1? 3.1, we know that t1 plus t2 is equal to 2. This is a geometric series. And we know that on our geometric series, the first term of a geometric series is represented by the letter a. And the second term of the geometric series is represented by AR, so it's equal to 2. So let me just highlight something. You still remember when we said the Tn of a geometric series is the same as ARn minus 1. So if we want term number 1 of a geometric series, it's always easy. How do we get it? We get it by just substituting n by 1. So it's going to be AR1 minus 1, and we end up having A. And t2 again we substitute, so we're gonna have ar2 minus 1, and we end up having ar. So basically now we are substituting t1 by its value a and t2 by our value of ar. So now we can see that according to your rules which you're taught, we know that a is a common factor here, so it's gonna be 1 plus r equal to 2. So they said write down an expression of a in terms of r. So now we just need to make a the subject of the formula. So we divide both sides by 1 plus r, 1 plus r, 1 plus r. Then therefore our a will be equal to 2 over 1 plus r. So this is our a. This is our first term. Now this is where the question starts to be a bit tricky. Now they say calculate the value of a and r. Now they are telling us to calculate the value of a and the value of r. So how can we do that? Calculate the value of a and r. How can we do that? Okay. We know that our sum to infinity, we were told here, our sum to infinity is equal to 1 over 4. And you know that sum to infinity is only comprising of t1 plus t2. Okay. Plus our summation. Okay. What is our summation? It's from n is equal to 3 to infinity. Then we have tn here. So we know that this is how we will be able to calculate the value of a and r. What is t1 plus t2? We were told that initially t1 plus t2 is equivalent to 2. So we'll put our 2 there then. So we have 2 plus. What is our summation equal to? We were told in our question that the summation is equivalent to this part. Let me just use something different so that you can see what I'm talking about. This part, under this part, is equivalent to 1 over 4. So we can just put our 1 over 4. So we have our 1 over 4. Then therefore our sum to infinity will be equal to 2 plus 1 over 4. What is 1 over 4? 2 plus 1 over 4. Then we'll end up having 9 over 4. Use your calculator always. Then now we know that our sum to infinity is equal to 9 over 4. Sum to infinity is equal to 9 over 4. What is our sum to infinity? We know that our sum to infinity is a over 1 minus r. Where is it? Let me check something. Yeah, we know that it's 1 over r. We know that the formula of the sum to infinity always, as I highlighted earlier, that sum to infinity, let me just write it here so that you see it, is you calculate by saying a is equal to a over 1 minus r. This is the formula to calculate the sum to infinity. So basically now we are saying that since our sum to infinity is equal to 9 over 4, we will have a over 1 minus r is equal to 9 over 4. Then we manipulate everything so that we can have our equation 1. Okay, so our cross multiply, we have 4a is equal to 9, 1 minus r, plus 4a is equal to 9 minus 9r. Let's maybe say equation number 1. No, equation number 2. Let me just highlight this one where we had earlier that this is our equation. No, this is my equation 1, sorry. Since it's my equation 1, so now let's substitute where there is a with what we get there. Substitute equation 1 into equation 2. So we have 4. What is our a? Our a is where is our a? Our a is 2 over 1 plus r. So we have 2 over 1 plus r is equal to 9 minus 9r. Then it's gonna be 8 over 1 plus r equal to 9 minus 9r. Then after that we'll be able to calculate. Then we know we cross multiply and we end up having 8 is equal to 9, 1 plus r, and minus 9r, 1 plus r. Then 8 is equal to 9 plus 9r minus 9r. Oh, it's r here. Yes. Then minus 9r squared. So we have 8 is equal to 9. This is 0 minus 9r squared. Then we go 9r squared positive because we are transposing. Then plus 8 minus 9 is equal to 0. Then we have 9r squared. Then 8 minus 9 is negative 1 is equal to 0. Then again our r now will be equal to 1 over 9. Manipulate to transpose 1 to that side and divide both sides by 9. Then we want r not 1 over r. 1 over 9. We don't want r squared, we only want r, so we square both sides. And when you square both sides, you can have two signs, plus and minus. Then we end up having our r to be, what is the square root of 1 over 9? It's plus or minus 1 over 3. But now you have to conclude what is your r. Your r is always the positive number, which is 1 over 3. So that's it. Oh, now we must determine our value of a, sorry. And we said our a, where is it initially? Our a is 2 over 1 plus r. So definitely we'll just come and substitute our value of a. So our a will be equal to 2 over 1 plus, what is our r? Our r is 1 over 3. Then we use our calculator. And when you use your calculator, we'll end up having our a, which is equivalent to, use your calculator, we have our a equal to 3 over 2. So that's how you determine that last question. If you have more questions, don't hesitate to ask on the WhatsApp group. Don't hesitate to ask also on the chats. Thank you so much for joining us today. Thank you so much. Have a blessed night, and we'll meet again on Wednesday for physics. And be there on time, and don't hesitate to ask questions. Don't forget to subscribe. Don't forget to like on our YouTube channel. Till we meet again, have a blessed night.